Hi, this is Ms. Warna. We're going to continue stoichiometry by looking at the idea of percent yield. So in a reaction, once you perform the reaction, you're going to get an actual yield. This is the amount that after you're in the lab, you physically do the lab, you actually form this product. Okay, so the actual yield must be given to you in a problem, in a question, or you could have actually performed a lab in which you physically measured the actual yield. The theoretical yield, that's what we've been calculating this whole time. This is on a piece of paper where you're giving the amounts of your reactants and you're asked to calculate how much product you're going to get. That was always the theoretical yield. You did this from the stoichiometry calculations. The percent yield is a ratio of the actual yield to the theoretical. It measures the efficiency of the reaction. It is usually less than 100%. Due to equipment error, human error, contamination. It would be odd if you got over 100% yield. You probably have accidentally added something to it. It would, like I said, be highly unlikely to get over 100%. Here's the equation for percent yield. Just so we said, it's the ratio of the actual yield to the theoretical yield. And because it's a percent, remember to multiply by 100. So here we have some aluminum being placed in some copper 2 sulfate, and you're getting aluminum sulfate and copper. Notice that on these coefficients, I did not write that understood one. If you remember from reactions, we don't write understood ones. I have written them in the previous videos just because I was wanting you to get used to the mole ratio, but you do not write understood ones. All right, so this question says, if you have 4.65 grams of copper are produced when 1.8 grams of aluminum reacts with excess copper 2 sulfate. So we know the amount of copper that's produced. So when it says what's the actual yield of copper, it's 4.65 grams. That is what was actually produced. What was the theoretical yield? What in theory should you have gotten? Well, if you start with 1.87 grams of aluminum, and it says excess copper 2 sulfate, so thank goodness this isn't a limiting reactant, so we can just do this in one step. You're not in moles, get to moles. And then, of course, we're in moles of aluminum. We need to get to moles of copper. And we look at our balanced equation for that. We have, looks like in front of the copper is a 3, in front of aluminum is a 2. Remember, the heart of a stoichiometry problem is the mole ratio. We need to get to grams. So now that we're in moles of copper, we can get to grams of copper. And we get this from our periodic table. And so when you multiply everything across the top, 1.87 times 1 times 3 times 6, 3.55, divided by 26.98, divided by 2, or you get in your calculator is 6.60703. And of course, with the 3 sig figs, the answer is 6.61 grams of copper. Okay, what's the percent yield of copper? Okay, remember that percent yield is going to be percent yield is going to be your actual yield over your theoretical yield times 100. So our actual yield from the problem is 4.65. Theoretically, we should have got 6.61 times 100. And what we get is 70.35%. Remember, percentages carry out 2 decimal places. There's another one. It's the same problem, but it says a chemist began with 200 grams of copper 2 sulfate. After collecting and drying the product, 61.9 grams of copper was obtained. Remember, notice this is drying, so it's probably filtered. Remember, if you don't dry it, then the mass would have included water. So anytime you filter something, you always need to make sure it's dry so that you don't include the mass of the water there. Notice in this problem, it doesn't mention the aluminum. It doesn't mention aluminum, so you can assume it's in excess. So what's the actual yield of the copper? It says 61.9 grams of copper was obtained. So the actual yield was 61.9 grams. The theoretical yield, well, we need to figure out if we started with 200 grams of copper 2 sulfate, how much how much copper should we have gotten? I'm just going to pull this out here. Use this. Let's see, this should have been. So we start by writing down our given. And then if you're not in moles, you need to convert to moles. Convert it to moles. And this most important steps, the mole ratio. Notice that this is a 3-to-3, which ends up being a 1-to-1. It doesn't matter. You still have to include this step. And if you skip it, you lose points. And then once you've converted to moles of copper, you can get to grams of copper. And when you calculate this, we should have gotten, in theory, 79.6 grams of copper. But we didn't. So what then is the actual, the percent yield? Well, then we do the actual yield, which was in the problem is 61.9. We divide it by the theoretical yield, 79.6 times 100, and we get 77.76 as the percent yield. And notice up here that, once again, I did not write understood once. Questions? Well, let's see here if I can move this screen forward. Yay! This concludes video 5 on stoichiometry. You should have taken high quality and in-depth notes with examples. Rewatch the video as needed and ask questions.